Okay, I'm going to be recording a solution to the quiz 12. So question number solutions. So one of the versions is n squared x plus 4 to the power of n over 7 to the power of n, and from 1 to infinity. In this case, Cn is n squared over 7 to the n, and a is minus 4. So if you calculate Cn over Cn plus 1, that gives you n squared over 7 to the n divided by cancel the 7s, so that gives you one more 7 left. So take the limit Cn over Cn plus 1 as n approach to infinity. This is the limit of 7 n over n plus 1 squared, and n approach to infinity. This goes to 1 n over n plus 1. 1 squared is 1, so that gives you 7 times 1 squared. So this is your radius of convergence. So the open interval would look like minus 4 minus 7, minus 4 plus 7, because minus 4 is the center and 7 is the radius. This gives you minus 11 and 3. So that's the open interval convergence. So that's solution C. That's for B. A was asking us for the center of expansion. Question number 2. In this version, I have f of x equals e to the power of 4x, and it asks us for f prime of x, which is 4 e to the power of 4x. F double prime of x is 16 e to the power of 4x. F triple prime of x is 4 to the thirds e to the power of 4x. And f to the fourth derivative of x is 4 to the fourth derivative of e to the power of 4x. And f to the nth derivative of x obviously is 4 to the power of n is the power of 4x. Okay, this is first part A. For part B, they ask us for the derivative at 0, which is 4. E to the power of 4 times 0 is 1. Second derivative at 0 is 4 squared. Third derivative at 0 is 4 cubed. Fourth derivative at 0 is 4 to the fourth. And the nth derivative at 0 is 4 to the n. That's the second part. And the Taylor series expansion centered at a equals 0 is now in an expanded form. It should look like f of 0 plus f prime of 0 over 1 factorial x minus 0, 4 squared over 2 factorial x minus 0 squared. So that's what it is, but what we want from you is 4 to the power of n over n factorial times x to the power of n, x minus 0 to the power of n, n from 0 to infinity is the final answer. So this is the final answer. Third problem is again Taylor series expansion. F of x equals natural log of 4x is what I see here on this version. Take the derivative. Well, the derivative happens to be 1 over x. You try to do a 4 and stuff. No, the derivative is just 1 over x. Okay, there's many ways that you could do the calculations. It's just 1 over x. You could do the chain rule. 1 over 4x times 4. That gives you 1 over x. That's the derivative of the inside. Okay, or you can rewrite it as natural log of 4 plus natural log of x. This is a constant, so the derivative is 0. So either way, derivative is 1 over x. The second derivative is minus 1 over x squared. Third derivative is 2 over x cubed plus 2 over x cubed. The fourth derivative is minus 6 over x to the fourth. Okay, and that's what they want. For the second part, they want the nth derivative. And as you can see, I have minus 1 to the power of n somewhere, or maybe n plus 1. We have to check. It's n plus 1 because when n is even, I want minus. And on top, we see n minus 1 factorial. And in the bottom, we see x to the power of n. So that's the nth derivative of the function f. Okay, there's multiple choice, so you pick whichever one. And then they want the Taylor series expansion centered at 1. So what's then the nth derivative of f at 1? That's minus 1 to the power of n plus 1, n minus 1 factorial over 1 to the power of n, happens to be minus 1 to the power of n plus 1 times n minus 1 factorial. That's the nth derivative of f at 1. Okay. So this nth derivative of f at 1 is minus 1 to the power of n plus 1 times x minus 1, n minus 1 factorial. So then the Taylor series expansion of f of x for x is f of 1, which is natural log of 4, plus the sum minus 1 to the power of n plus 1 times n minus 1 factorial over n factorial, that is fn derivative at 1, times x minus 1 to the power of n, n from 1 to infinity. Now this guy cancels with most of the n factorial except the n. Okay, so that gives you natural log of 4 plus the sum n from 1 to infinity of minus 1 to the power of n over n, x minus 1 to the power of n. And that's the final answer. All right. So this is it. I will post the solution on Moodle. All right, take care.